we're talking about the line spectrum, and we said that line spectra is specific for each of the elements, and we were looking at hydrogen. So hydrogen only has, 4 lines there on the line spectrum. And, kind of the question is, well, what's causing these lights, these colors to be emitted? What's happening? And Niels Bohr was asking that question, but he was specifically asking the question about hydrogen. He wasn't talking about anything else, just looking at hydrogen. And so he came up with his atomic model, and it's right here. So in the middle, the dot is the nucleus, so that has the protons and the neutrons, and these rings are called orbits. So I want you to remember that name, circle and highlight that name. So then we have, the first orbit by the nucleus is n equal to 1, and then the second one is n equal to 2, 3, 4, 5, and it just continues to go up. N equal to 1 is what we call the ground state. N equal to 1 is the lowest energy orbit possible. And then as we get higher, 2, 3, 4, 5, the energy increases with each orbit. So that's really important. That's something that we're going to continue with our current model. So again, we're looking at what's happening in those line spectra, what is responsible for causing that light to be emitted. So here's kind of his idea. So here we have the electron and n equal to 1, and he said that the electron just orbits the nucleus. And he also said that the n, we call them the principal quantum number, their energy levels are quantized. Now all that means is there's a specific amount of energy it takes to go from n equal to 1 to n equal to 2. It's kind of like a ladder that you see there on the left side. So in order to step up from n equal to 1 to n equal to 2, on that ladder, I'd have to pick up my foot a specific amount to get to that. It's not just a gradual increase for the electron to go from n equal to 1 to n equal to 2. It has to have enough energy, a specific amount of energy, to move into that higher energy level. And we call the n equal to 2 and above, we call those excited states. So, and that comment about classical physics. So when Bohr came up with this model, his physics friends didn't like it because they said that with the negative charge and the positive charge, eventually that electron would go to the nucleus, but that's not actually what happened. Okay, so here's what happens. So the electron can move into a higher energy level, into one of the excited states, if it absorbs energy. And remember, the energy levels are quantized, so that in order for an electron to move from n equal to 1 to n equal to 5, it has to absorb enough energy to be able to do that, because it's not a gradual increase, it's just going to hop from n equal to 1 to n equal to 5. But then the electron is not stable in that higher energy level, so it has to come back down, and it has to release the energy that it absorbed, and it does that by emitting light. So Bohr was correct. He had made the assumption that the electron and the hydrogen was responsible for the light that was being emitted, and he was correct in that. So just to kind of give you an idea here, if you look at, let's see here. So if we go from, see our electron, we have 1, 2, 3, 4. So our electron is in 4. And if it relaxes back down to 3, it's not moving a whole lot, right? It's not going to be releasing a whole lot of energy. And we said about energy and wavelength was that they're inversely related. So if I have lower energy, then I'm going to have a longer wavelength. So just to give you an idea here. So remember, the reds were longer than wavelengths. So if I'm emitting less energy, I'm going to have a red color. But if I'm emitting more energy, so you can see with the electron moving from 5 to 2 or 4 to 2, okay, that's more energy, then we're going to have a purple or a blue or a green color. So based on where the electron is relaxing down to and how much energy is being emitted determines what color is going to be emitted. So Bohr's model only works for hydrogen. So if you add in another electron, his model actually does not work. So, because remember I said he was only looking at hydrogen. So we do take some things away from, his model, like the energy levels that are quantized, the electron being responsible for emitting the light. So these things, he was correct. But really, the orbit, that was incorrect. The electron is not in an orbit, like he said. It's actually a probability of where we find the electron. So if you look at this apple tree, if apples start to fall from the tree, there's a high probability they're going to be close to the trunk. So that's what our graph is showing us there. It's the number of apples in each ring, distance from trunk. So there's a high probability that if we walk towards the trunk, we're going to find an apple on the ground. So that's kind of the idea, but in 3D with the atom and where to find the electrons. It's all about probability.